There's a broad stretch of the country stretching from the Ohio Valley into the mid-Atlantic, waking up right now under a genuine severe weather alert for tomorrow. Temperatures pushing into the 90s, an atmosphere loaded with moisture, a front that's refused to move for days, and sheer numbers strong enough that, on paper, this is exactly the kind of setup that makes meteorologists start talking about tornadoes. Except that's not actually the headline here. Despite everything lining up for a textbook severe weather day, forecasters are telling residents the tornado threat stays low. While a completely different hazard, one that gets far less attention in most severe weather coverage, is the one actually driving today's alert. That's the twist, and it's a genuinely useful one to understand, because it's not a one-off quirk of tomorrow's forecast. It's a pattern showing up across a huge stretch of the country over the next several days, and knowing how to read it could change how you prepare. This is exactly the kind of forecast that trips people up if they're only half paying attention. See severe weather, impressive shear, and large area at risk in the same sentence, and the instinct is to picture rotating supercells and tornado sirens. That instinct would be wrong here, and understanding why is genuinely useful, not just for tomorrow, but for reading severe weather forecasts correctly for the rest of your life. Today, we're breaking down exactly what's setting up for Tuesday, why the tornado risk and the overall severity of this threat don't line up the way you'd expect, and where this same pattern is headed as we move deeper into the week. All of it straight from the forecast data, no exaggeration required, because the actual meteorology here is interesting enough without it. Quick note before we start. Subscribe if you want. Tomorrow's update, the moment new data comes in, it's free and it helps a lot. And drop a comment letting me know if you're anywhere from the Ohio Valley through the Mid-Atlantic, because this one's heading straight for you. Let's start with the setup, because understanding exactly why the system is built the way it is explains the twist itself. A quasi-stationary front, meaning a boundary that's essentially parked in place rather than sweeping through and clearing out, has been sitting across the region for the better part of a week now. Ahead of it, temperatures have been climbing into the 90s, and the atmosphere has been steadily loading up with moisture, exactly the fuel a thunderstorm needs to grow. Tomorrow, that stalled boundary is expected to finally kick off a stronger line of thunderstorms than the region has dealt with in recent weeks, expected to move through sometime in the window between 1 p.m. and 9 p.m., with the greatest chance for actual severe weather concentrated in the late afternoon hours. Exact timing is genuinely uncertain this far out, and depends heavily on how quickly storms fire up during the morning hours over the Ohio River Valley. If that first wave comes in stronger, it can actually sap energy away from the atmosphere, weakening whatever tries to develop later in the evening. If it stays weaker, the door stays open for a more organized, more dangerous line later in the day. Here's the key detail on how this system is shaping up. Given the setup, with that quasi-stationary front acting as the trigger, conditions favor a linear storm system. Essentially, a long, organized line of thunderstorms marching forward together rather than scattered, individual, rotating supercells. And that distinction in storm mode is the entire reason this system's biggest threat isn't what you might expect. A linear system like this one is built to produce damaging straight-line wind, not tornadoes, and the physics behind that distinction is worth actually understanding rather than just taking on faith. Tornadoes overwhelmingly form from discrete, isolated supercell thunderstorms, storms that have room to develop their own independent rotation because they're not packed in shoulder to shoulder with their neighbors. When storms instead organize into a solid, continuous line, as they're expected to do tomorrow, that packed-together structure tends to suppress the kind of isolated rotation tornadoes need to form. Instead, all that atmospheric energy gets funneled into forward momentum and outflow, cold, dense air rushing out ahead of and beneath the storm line, which is exactly what produces the damaging straight-line winds that make squall lines and their more intense cousins, derechos, so dangerous over such a wide area at once. This is exactly why forecasters can look at genuinely impressive wind shear values tomorrow, the kind of numbers that would normally get a meteorologist's attention for tornado potential, and still confidently say the tornado threat stays low. Shear on its own isn't the whole story. It has to be paired with the right storm mode to actually translate into rotating, tornado-producing updrafts. With a linear system dominating tomorrow's setup, that shear is far more likely to show up as an intense wind gust radiating out ahead of the line than as a tornado touching down. That said, low doesn't mean zero, and forecasters have been clear that the greatest tornado risk within this overall system sits farther west, over parts of the Midwest, where the storm mode has more room to stay discrete rather than immediately consolidating into one continuous line. Anyone in that corridor should treat the threat as genuinely low probability, but not something to dismiss outright. It's worth understanding just how powerful the wind side of this equation can actually get, because damaging straight-line wind can sound like a lesser hazard than a tornado when it's often anything but. When a line of storms like this one becomes strong and well-organized enough, It can develop what meteorologists call a bow echo, a segment of the line that visibly bulges forward on radar, shaped like an archer's bow, marking the spot where a concentrated pocket of descending air is punching down to the surface hardest and pushing outward the fastest. Wind gusts embedded in a strong bow echo can regularly reach 70 to 80 miles per hour, equivalent to a strong tornado's winds, but spread across a much wider swath of real estate and capable of downing trees, snapping power lines, and damaging roofs across dozens of communities in a single line's path, rather than the narrow, mile or two wide track a typical tornado carves out. If a line like this one grows large enough and sustains itself over hundreds of miles for many hours, it earns an even more specific name, a derecho, a long-lived, fast-moving windstorm capable of producing damage comparable to a hurricane's wind field along its entire path. The Midwest has seen genuinely historic examples of this exact phenomenon, including a derecho that tore across Iowa and neighboring states in August of 2020, causing billions of dollars in damage and widespread, prolonged power outages, almost entirely from wind, with barely a tornado warning issued anywhere along its path. Tomorrow's system isn't currently forecast to reach that same historic scale, but it's built from the exact same basic ingredients, which is part of why the wind threat deserves to be taken every bit as seriously as a tornado threat would be, even though it doesn't carry the same visceral sirens and funnel cloud imagery. So that's twist number one, a system carrying enough energy and shear to sound like a major tornado threat, delivering its real danger through wind instead. Here's twist number two, and it's the one that actually poses the broadest risk across the entire region tomorrow: flooding. Storms embedded in a slow-moving linear system like this one don't just produce wind, they're also capable of dropping torrential rainfall in a short window of time, and because the parent system is moving relatively slowly, thanks to that same quasi-stationary front steering it, any spot that gets hit by a strong cell is at real risk of flash flooding before the rain finally clears. This is the same basic mechanism that's been showing up across the broader Midwest and Ohio Valley for days now, and it's part of a genuinely useful pattern to recognize. Slow-moving, severe weather systems are frequently more dangerous for flooding than for wind or tornadoes, precisely because the same characteristics that limit tornado potential, storms packed together, moving as one unified system, are exactly what allows repeated rounds of heavy rain to train over the same communities again and again. The National Weather Service's own excessive rainfall outlook has been flagging exactly this risk across a broad stretch of the Midwest and Ohio Valley through the early part of this week, with the heaviest, most concentrated rainfall totals expected along an axis running from northern Indiana down through western Ohio, where localized totals exceeding 3 inches carry a genuinely elevated probability. That heavy rain threat is expected to shift and expand as the week continues, with forecasters now also flagging Indiana and Ohio extending into West Virginia for a period of locally significant heavy rainfall, as a series of stronger disturbances move quickly through the broader flow. If you're anywhere in that corridor, the flooding risk deserves at least as much of your attention tomorrow as the wind does. Arguably more, since flash flooding is responsible for more weather-related fatalities most years than tornadoes or straight-line wind combined, and it's precisely the hazard that gets the least attention in casual, severe weather conversation. It's worth understanding why slow-moving systems flood so much more efficiently than fast-moving ones, because the mechanism is simple once it's laid out. Rainfall totals are a direct function of both how hard it rains and how long any single spot sits underneath that rain. A fast-moving storm might produce an intense downpour, but it clears out within 20 or 30 minutes, capping the total accumulation even if the rain rate briefly spikes. A slow-moving system anchored to a stationary front, the exact setup driving tomorrow's storms, can park nearly identical rain rates over the same community for hours instead of minutes, a phenomenon meteorologists call training, because successive storm cells move through like train cars following the same track one after another. Two locations can experience the exact same peak rainfall intensity and end up with wildly different total accumulations, and therefore wildly different flood risk, purely based on how long that training behavior persists over their specific rooftop. Now let's zoom out, because tomorrow's system isn't an isolated event. It's the leading edge of a broader pattern that's expected to keep the middle of the country unsettled well into the back half of this week. According to the Storm Prediction Center's extended outlook, a broad mid-level cyclonic flow pattern, essentially a persistent dip in the jet stream, is forecast to sit over the Great Lakes in the northeast from Wednesday through Friday, while a ridge of high pressure moves eastward out of the northern Rockies and into the upper Mississippi Valley behind it. At the surface, that same cold front we've been discussing is expected to remain quasi-stationary, stretching from the central and northern plains down into the mid-Missouri and Ohio valleys, continuing to act as the focal point for low-level convergence and fresh thunderstorm development, essentially every single day, rather than clearing out after one round and moving on. On Wednesday specifically, model guidance points towards scattered thunderstorms developing along an axis of moderate instability stretching from western Nebraska into southwestern South Dakota, supported by a mid-level shortwave trough sliding across the north-central United States. In practical terms, that means the corridor from the plains through the Ohio Valley and into the mid-Atlantic should expect the same basic pattern: repeated rounds of thunderstorms, a wind-dominant severe threat riding along a mostly stationary boundary, and a real, recurring flooding risk to keep reasserting itself day after day rather than resolving in one clean event. There's a broader reason this kind of stubborn, repeating pattern keeps showing up this particular August, and it connects directly to the bigger climate story we've been tracking on this channel. This entire summer has unfolded under the influence of a rapidly strengthening El Niño, one that crossed into very strong territory on the Key Ocean Monitoring Index just last week for the first time in a decade. One of the well-documented effects of an event this strong is a more amplified, more sharply buckled jet stream, prone to getting stuck in place for days at a time rather than moving smoothly west to east the way it does in a calmer pattern. A stuck jet stream produces exactly the kind of quasi-stationary fronts and repeating storm tracks we're seeing right now, the same basic ingredient behind both tomorrow's severe threat and the broader multi-day unsettled pattern the Storm Prediction Center is tracking through the rest of the week. None of that makes any single day's forecast a certainty, but it's a useful piece of context for why this particular stretch of summer has felt so persistently active and, at times, genuinely strange. It also helps explain why this specific kind of twist, a big, headline-worthy severe threat that underdelivers on tornadoes but overdelivers on wind and flooding, has been showing up so often lately rather than being a rare fluke. A jet stream that's buckled and stuck tends to produce exactly this storm mode: slow-moving linear, front-anchored systems over and over, rather than the faster-moving, more discrete supercell setups that dominate tornado climatology in a more typical zonal summer pattern. If this pattern holds through the rest of the month, as the Storm Prediction Center's extended outlook currently suggests it will, expect more days like tomorrow. Big areas outlined for severe weather, genuinely impressive atmospheric ingredients on paper, and the real headline ultimately landing on wind and water rather than tornadoes. Let's talk practically about what all of this means for you, region by region, because the advice actually differs depending on where you sit relative to this system. Before we get into the regional breakdown, it's worth taking a moment on the distinction between a severe thunderstorm warning and a tornado warning, because how you should react to each one is genuinely different, and a lot of confusion during events like tomorrow's comes from treating them interchangeably. A tornado warning means rotation has been detected on radar, or confirmed by a trained spotter, and the correct response is to get to the lowest floor of a sturdy building into an interior room away from windows immediately. A severe thunderstorm warning, which is far more likely to be the warning type issued during tomorrow's event given the storm mode we've just walked through, means damaging wind of at least 58 miles per hour or hail at least 1 inch in diameter is expected. And the correct response is to get inside a sturdy structure and away from windows. But it doesn't require the same below-ground level interior room urgency a tornado warning does. Understanding that distinction in advance means you're not stuck making that decision for the first time while a warning is actively blaring on your phone. If you're in the corridor most directly in tomorrow's path, roughly the Ohio Valley through the mid-Atlantic, the wind threat is your primary concern during that afternoon and evening window. Straight-line winds from a mature squall line can reach speeds capable of downing trees and power lines just as effectively as a weak tornado over a much broader area at once. Secure or bring in anything outside that could become a projectile. Know which room in your home offers the most protection from flying debris, and have a reliable way to receive warnings that doesn't depend solely on your phone, since severe thunderstorm and flash flood warnings can arrive with less lead time than a typical tornado watch gives you to prepare. If you're anywhere along that heavy rain axis, from northern Indiana through western Ohio and now potentially extending into West Virginia, the flooding risk deserves your full attention regardless of how the wind and tornado questions resolve. Know your evacuation routes if you're in a flood-prone area. Never drive through a flooded roadway, even if it looks shallow or familiar, since it takes surprisingly little moving water to sweep a vehicle away, and keep an eye on rising water near your home if the heaviest cells happen to train directly overhead. And if you're farther west, in the Midwest corridor carrying the greatest, if still low, tornado risk within this system, treat that risk with appropriate respect, even though forecasters aren't emphasizing it as the headline threat. Low probability isn't zero probability, and the individual storms capable of producing an isolated tornado within an otherwise linear system are notoriously difficult to pick out until they're already organizing. Meteorologists have a specific term for this exact scenario: a QLCS tornado, short for quasi-linear convective system, referring to the brief, often weaker, harder to warn for tornadoes that can spin up along an otherwise wind-dominant line frequently forming and dissipating in a matter of minutes, with less lead time than a classic supercell tornado typically provides. It's precisely this kind of tornado that makes low but not zero the honest, appropriate way to describe risk in a linear system like tomorrow's, rather than dismissing the possibility outright just because the overall storm mode favors wind. Here's the honest summary of everything we just covered. Tomorrow's system has all the surface level ingredients that usually make meteorologists nervous about tornadoes: heat, moisture, and genuinely impressive shear. But the storm mode it's actually taking, a linear system riding along a quasi-stationary front, redirects nearly all of that energy into damaging wind and flash flooding instead. That's the twist. And it's not just a one-day story. It's the leading edge of a pattern the Storm Prediction Center expects to keep reasserting itself day after day, corridor after corridor, through the rest of this week, as a stubborn, amplified jet stream keeps this same boundary essentially parked over the middle of the country. Wind and water, not tornadoes. Are the hazards actually worth your attention here, even though it's the tornado question that would normally dominate the headline? The next time a forecast lands in your feed promising a large, severe weather area with impressive atmospheric ingredients, it's worth remembering this exact case, because the biggest area on the map and the most dangerous hazard inside it aren't always the same story. We'll be tracking this system through tomorrow afternoon and into the extended pattern behind it, bringing you the next update the moment the picture changes. Subscribe if you want, that followed in real time. Let me know in the comments if you're in the path. Whether that's the wind threat, the flooding corridor, or that low but not zero tornado risk out west, see you in the next one.